All right, I'm going to go through the Module 3 practice exam. I can tell you I'm redoing the exam for this unit. I don't necessarily want to get into proofs the same way that Buzz does it on the testing side. So I'm going to try to make the test a little clearer than some of their questions aren't so clear what they're asking. So I'm redoing that. But in the meantime, I want you to watch this review and practice to see how to solve some of these. It's really just knowing the properties that we've learned in this unit about angles and using the uh, transversal with parallel lines. So let's look at this first problem. It's a very long problem. In fact, the choices are on a second page. So pull our choices out for this problem. So we'll have those. All right, it says the following is an incomplete flow chart. They like the flow charts. Just different ways of doing proofs. There's just a bunch of different ways. Proving that the opposite side of angles of a parallelogram, JKLM, are congruent. So proving that they are the same length. All right. So since it's a parallelogram, we know that this is parallel to this. That's what the arrows mean. And then this has double arrows, meaning these two are parallel to one another. We can't use single arrows on all four sides because that would mean all four are parallel with each other. Clearly not. These are parallel, but this is not parallel with this one. So it has to have double arrows to indicate that it's parallel to the other side of there. So what are they saying? And we have a blank here and here that we need to figure out what is the theorem that would fit that. So extend JM beyond point M and draw point P. So we need to do that. JM, so we just make it a little longer and make point P. Okay, so this is by construction. Yeah, because we just did that. This one has to extend JK beyond J, JK beyond J. Okay, so we'll make that one longer and make a point Q, it says. Okay, so we've done the construction that they said, by construction. That's the reason for that, because we did it that way. Now this says MLK is congruent to PML. So where is MLK? MLK would be this angle. And they're saying that one is congruent to PML. PML. Okay, so this angle over here. So why would those be congruent? Well, they're alternate interior angles. Because look, we have two parallel lines with a transversal. So these are alternate, one on each side of the transversal, alternate, same side. They're not consecutive. They're not same side. They're alternate. And they're interior. That means they're inside those parallel lines. See, both angles are inside. Exterior would mean they're on the outsides, but these are on the inside. So these are alternate interior angles. And it tells us that. It also, when the other one says JML, JML is the same as QJM. QJM also by alternate interior angles. These are parallel with a transversal. So they're inside the parallel lines, right? They're interior. Alternate means one's on each side. So those, by the alternate interior angles, are congruent to one another. So now what is it saying? It's moving on to say PML, okay, PML, so that's this one, is congruent to KJM. KJM. So it says that these two are congruent to one another. Why would those be the same? Those are corresponding angles. They're in the same place. Remember, if we have two parallel lines, and we're saying those are parallel, and we have a transversal, angles that are in the same place in both lines, like this is on the bottom corner down here, this angle. So it's going to be the same as the angle that's on the bottom corner up there. They correspond with each other. They're in the same place, corresponding angles. In the same way, this one on this side would be the same as this one on this side. They're both beneath the parallel lines and on the left side. The same position, those are corresponding. So these two are the same by corresponding angles. So that is number one, corresponding angles right there. Not same side interior, not same side interior, not alternate interior. So we already know the answer has to be that one. That's the only one that has number one as corresponding. Let's double check corresponding number two. Number two says that QJM is, that's this one, is congruent with LKJ. Oh, same principle. Transversal, two parallel lines. They're both on the top corner. The blue one up here and the blue one up here. They're in the corresponding. They're in the same place of both those intersections. So that is our correct choice. Corresponding angles theorem for both of those. So it's just knowing the corresponding angles, alternate interior angles, same side interior angles. That's the kind of things we're looking for in this lesson, understanding those angles, which means you might want to make a cheat sheet on the test to know that these are corresponding, to know that alternate interior would be this one and this one because they're inside the parallel and they're on each side, which means it's also this one and this one, right? Because there's two sets of alternate interior angles. And those angles would be exactly the same. If this one's 70, this one's 70. Corresponding. If that one's 70, then this one down here is 70. Corresponding angles are the same. Alternate interior angles are the same. Vertical angles across from each other, those are the same. These are the same, vertical. So having a cheat sheet of all that is great because you can use your notes. All right, let's look at the second problem. Okay, this is triangle ABC is a right triangle. So that means this is a 90-degree angle. That's a 90-degree angle because it's a right triangle. Point D right here is the midpoint of AB from here to here. Now, in the drawing, that certainly does not appear to be true. It's this D is in the middle between A and B, which means this is the same distance as that. We look at that and we said, no, it's not. This is longer than that. But since it is stated in the problem, then you ignore that the drawing is not drawn correct. Since it says it, then we say, okay, yes, it is the midpoint. They just didn't draw it correctly. D should have been higher, right? If D was higher up here, that would be kind of in the middle. But we have to go with what they're telling us. Okay, that is the midpoint. And point E is the midpoint of A to C. So that is a midpoint. It means that is the same length as that. Okay, even though it doesn't look it, it's stated as a given fact for the problem. And it says the measure of angle ADE is 68 degrees, which they have marked for us right there. So what we have is we have a triangle right here that has a 90-degree angle. We also have a larger triangle right here that has a 90-degree angle. They both use that same angle here, just one triangle is larger. Now it says the following flowchart with missing statements and reasons proves that the measure of angle ECB is 22 degrees. ECB, this one right here. Okay, they're saying that's 22 degrees. And this is how they prove that. So they said, let's see, here's number 1, number 2, and number 3. So let's go ahead and start with number 1. This says, and it's kind of hard to see, it's bring it a little closer in, maybe help you out there. Refocus. Okay, it says segment DE, this goes across there, DE, joins the midpoints of segments AB and AC. Yeah, because these are midpoints it told us, and so that just joins it. That's given. Segment DE is parallel to BC. DE is parallel to BC because of the mid-segment theorem. And the mid-segment theorem says if you have two midpoints and you connect them, it is going to be parallel to that side of the triangle, that third side of the triangle. So this is going to be parallel to that by the mid-segment theorem, because we said these are midpoints. So that makes those parallel. Okay, so then it says angle ECB, that's the one that we have marked there. I'm going to mark it in yellow. ECB is congruent to AED. So it says these are the same. Why would those be the same? Why would this angle be the same as this angle? Well, we have two parallel lines with a transversal, right? even though it's part of a triangle, it's two parallel lines with a transversal. That's the transversal that cuts through those two parallel lines. And so it's talking about this angle and this angle. What kind of angles are those? They're not alternate interior. They're not same side interior. They're not vertical angles. Those are in the same position. They're both on the top left, which makes those corresponding angles. So number one has to be corresponding angles, which means it could be this one, it could be this one, but they're not alternate interior angles. So we've already crossed out two of our answers because it cannot be alternate angles for number one. So we just have to follow it and see what it's saying. So this says the measure of angle ADE is 68 degrees. Yes, it is, given. And we're saying something because of that. And this is the measure of angle DAE, that's right up here, is 90 degrees because it told us it's a right triangle. So since it's a right triangle, we know that it's 90 degrees. All right, so we've got 2 and 3. 3 is talking about the measurement of AED. So it's either 22 degrees or it's 68 degrees. Well, what is it? A triangle adds up to 180 degrees. Every triangle adds up to 180 degrees, the 3 angles. We have a 90-degree angle right there, so there's half of our 180. So we already have a 90-degree angle, so we have 90 left. This is 68. So the last one has to be a 22-degree angle. 90, 68, 22 makes 180. So that's this one. This has to be our answer because of the triangle sum theorem. The triangle sum theorem says that all the angles of a triangle add up to 180 degrees. So because the triangle sum theorem right there, we know that's 22 degrees. Process of elimination, looking to see what it's saying is true, and we can eliminate answers till we get to the correct one. All right, number 3. PQ, all right, and RS are lines that intersect at point T. So then we're going to make that point. That's point T. That's T right there, as shown below. Which fact is used to prove that angle PTS, all right, let's mark that, PTS, so that's the one that they have marked right there, is always equal to RTQ. Okay, well, looking at those, we know they're vertical angles. It's actually the vertical angle theorem would tell that. But when we look here, that's not one of our choices. So we can't use the vertical angle theorem because they didn't give us a choice. If they did, that would be the answer. Those are vertical angles. So the vertical angle theorem says those are always going to be equal. 2 lines intersecting, opposite sides of that is vertical angles. I'd point out this one and this is also vertical angles, so they would be equal to one another. But let's see what they did list, and let's find out what's true and what's not true. So let's start with the top. The sum of the measures of angle RTQ, okay, so that's this one, and QTS, that's this one. So let me mark those in pink. So it's saying this one plus this one is 180 degrees. Well, that's a true statement because when you add those together, 180 degrees makes a line. 180 degrees is half of a circle. That would be half of a circle because that's a straight line. That is true. All right, let's see what other choices are. Line PQ and RS intersect at an angle greater than a right angle. Well, that depends on which angle we're looking at, right? If we do a right angle would be like right there. Yeah, they intersect at a greater right angle. Unless I'm looking at this one, then they're less than a right. That really has nothing to do with anything. Because I could say if I'm looking at this angle, it's not greater than, it's less. So I don't, that doesn't have anything to do with it. Line segments PQ and RS do not have a fixed length. Well, how long this line is, does that have anything to do about angles being the same? That has nothing to do with an angle on how long the side is. It doesn't matter if it's a big triangle or a little triangle, they can have exact same angles. That doesn't tell us anything about the angle. The sum of the measures of angle, okay, let's mark this. PTR, P to T to R, this one, and QTS, oh, the opposite one over there, says that's 180 degrees when you add those together. Well, that is only true if this is at a right angle. That one's 90 and that one's 90 because those are vertical angles. They have to be the same. Well, they're not perpendicular. It's not at a 90-degree angle. If it was at a 90-degree angle, then opposite angles would be 90 degrees. And so that's not true. It's only true with one specific case, and it's not true here. So this is the only statement that's even true. So that has to be the fact that we used, just because those others aren't even true for this diagram. Okay. Here we have two parallel lines with a transversal. Right? We use that a lot here in geometry. Maria drew two parallel lines, KL and MN, intersected by the transversal PQ. Okay, which theorem could Maria use to show the measure of angle KRQ, so that's this one they have marked, is equal to the measure of angle PSN, so that's this one. So let's mark the two of them. So they're talking about this angle and this angle. What tells us that those angles equal each other? Well, here's the parallel lines. They're both inside the parallel line, so they're interior angles. Here's the transversal. One of them is on the left, one of them is on the right, so they alternate. These are alternate interior angles. So the alternate interior angles theorem tells us that those angles equal each other. Exterior angles, that would be like this one and this one. Alternate exterior, outside of the parallel lines. See, that would be exterior. Same side interior would be this one and the one above it. And those are not equal to each other. Those equal 180 degrees. And vertical angles would be like this pink one and this one over here, right? Across from each other, or this one and this one down here would be vertical angles. So this is alternate interior angles. That's going to be our answer. All right, number 5, look at the figure below. Which steps should be used to prove that point B, P is equidistant from R and Q? So it's saying the distance from P to R is the same. Let's go ahead and draw that just so we can look what they're saying. They said the distance from P to R is exactly the same as the distance from P to Q. Said those are the same. How can we prove that? Well, it says if we use the angle side postulate, that proves that PQS and PRS. So angle side, how can we prove that two angles are the same? Well, we know that one angle is the same. This is a 90-degree angle. So that means the other side has to be a 90-degree angle. So these two angles do equal each other. There's no doubt. This has to be 90 over here also. So we have an angle that's equal, but we don't have a way to prove these other angles are the same. So it doesn't look like we can do that. Let's see, side angle side. Well, we know that this side equals this side. They haven't marked for us. So can we prove, we have two triangles. Can we prove another side is the same? Well, actually we can, because if we look at this triangle here, okay, look at that triangle. See the side PS that's right next to the ruler? Let's look at this triangle over here. This triangle, see the side PS? That's the same length as the PS in this triangle. That PS is the same as this PS. And you know how we know that? Because it's the same line. This is equal to itself. And that is the reflexive property. The reflexive property says something is equal to itself. Like looking in a mirror, reflecting, reflexive. It's going to be the same size. It's going to be the same length. That is the reflexive property. So we do have, if we look at it, a side, another side, and an angle that's in between the two sides, which is side angle side. We can use the side angle side postulate. Again, angle side angle or angle angle angle. Angle 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 proves they're similar triangles, right? And this ASA they're saying proves similar. That's not going to prove that it's the same as this one if they're similar triangles. They have to be congruent, right? So we got to look for that word. And with that, this is the only one that we can prove. So it's the little pieces that we're looking at. All right, let's look at this. The figure shows triangle ABC, this big triangle, with medians. Medians, that's midpoints. It's in the middle. Okay. AF is a median, which means it's drawn from the midpoint of F to the opposite. That's called a median, from the midpoint to the opposite vertex. So this is a median, this is a median, this is a median. So all three of these are midpoints. We know because of that. We know that D, E, and F are midpoints because those are medians. Segment AF is extended. AF is extended all the way to H, so that in such a way that segment GH is congruent to AG. So it's saying that this is the same distance as this one down here, all the way to H. So that means G is a midpoint of AH. All right, so G is a midpoint of AH. It's not a midpoint of these other medians, but since they extended that to H, from G to H, that's a midpoint. Now, note this is not a triangle. It's a quadrilateral when we go all the way down to H. It's only a triangle we cut across, but it now makes two triangles. We have this triangle over here, and we have this larger triangle over here. So what conclusion can we make? Can we conclude that segment GF is congruent to EG? GF, let's see, is this little short one right here. GF and EG. Can we conclude that? No. In fact, it even looks shorter here. That would only be true if this was an equilateral triangle. If every side of the triangle is exactly the same length, then the medians would intersect and be all the same length. All the medians would be the same length, and that would be true. But this is not a triangle that's the same length on every side. Nothing told us that. We can't make that assumption. So we can't make that conclusion. GF is half the length of EB. GF right here, just the short part. EB. We have nothing conclusive to say that this is half the length of this. GD, right here to here, is congruent to EG. We can't conclude that these two line segments are equal to each other because, again, it's not an equilateral triangle. We don't have a conclusive way to do it, so it doesn't look like that one. How about GD? Let me draw this. We're running out of options and getting hard to see all this. GD is half the length of HC. HC. Well, if we look at this whole triangle, all right, I want to draw the whole triangle that the HC makes. In a triangle, we know that these are both midpoints. So if those are both midpoints, then that means this is exactly half the length of the parallel side. In any triangle, all right, let me draw another triangle. If we have the midpoints, and I'm saying these are midpoints, and I connect those, that tells us two things. First of all, it tells us these are parallel. If these are the midpoints, that's going to be parallel. It also means this is exactly half the length of that, if these are midpoints. Parallel, half the length. So GD would be half the length of HC because of the mid-segment theorem, because that is a mid-segment. It's in the midpoints connected, mid-segment from the third side of the triangle. And it would also be true if we had a midpoint here and connected that. That means that would be parallel to this side, and it would be half the length of that. We could do that 3 times in any triangle. All right. I think this is our last page right here. This figure below shows a rectangle, ABCD, having diagonals AC and DB. Jimmy wrote the following proof to show that the diagonals are congruent. So he's saying that this is the same length as this, corner to corner, right? So he said in triangle ADC, so he's looking at half of it, ADC, and BCD. So he's taking 2 triangles out of this, right? Let me draw that for you visual folks. So he said, look at these two triangles. Okay, see those two triangles now. He says, in those two triangles, AD and BC are the same. He says, AD equals BC. All right, let me go and erase these original marks I put up here just because that's what we're trying to prove. So he said, these are the same. And why? Because opposite sides of a rectangle are congruent. That's true. That's why it tells us it's a rectangle. So because they told us that, there's some basic assumptions that we can take as fact. And that is that these sides are the same length and these sides are the same length. And all four of these corners are 90 degrees. We know that that's given in a proof because we're given that it's a rectangle. That is true of all rectangles. These are the same. These are the same. These are all 90-degree corners. So he can say that. So then he said angle ADC. ADC. He says this angle is the same as angle BCD because the angles of a rectangle are 90 degrees. So that would be true. Both of those angles would be 90 degrees. All right. So there's one statement missing. And so then he said that this triangle is the same as this triangle by the side angle side postulate. So he's missing something. Well, what did he prove before he was missing this line? He proved that this side is the same. So we have an S. He proved that these angles are the same. The angles. The third line must be the other missing side. Well, which side would that be talking about in these two triangles? You either have this one or this one. Well, if it was this one, that would not be side angle side. Side angle side means the angle, where's that at? Has to be in the middle between the two sides. That's side angle side. So side angle side has to be this side to make the angle in the middle. Well, how can we prove that this one that's pink is the same length as this one that's yellow? Because it's the same side. It's the same line, D to C, D to C. So DC equals DC, or DC. So it's not AB, because up there has nothing to do with it. AB has nothing to do with either triangle. It's true, DC equals DC, but which property tells us that? Is that the reflexive or is that the transitive? We just had the reflexive. We just talked about that. It's like a reflection. It's going to be exactly the same. It's the reflexive property, not the transitive. So the answer is DC equals DC because of the reflexive property of equality. That would be line 3 right there. So that would say AC equals BD because, let's go over this phrase. This is used often in proofs. AC equals BD. We've proven that these triangles are exactly the same. So then he said AC, which is the long hypotenuse of this one, is the same as the hypotenuse of by CPCTC. And what that says is corresponding parts of congruent triangles are congruent. Corresponding. What's corresponding means? It means it's the same part. If I'm talking about the hypotenuse of this triangle and I have another triangle that's exactly the same, then I can know that this is going to be the same as this because they're corresponding parts. They're both the same part. Like two cars. We're talking about the same part in two cars. The same part in two bicycles, whatever. This is the same part in two triangles. Those correspond with each other. This is the same as that. Corresponding parts of congruent triangles. Congruent means identical. It means the same. It means the angles are the same. It means the lines are the same. Oh, I don't need it. Corresponding parts of congruent triangles are congruent. Are congruent. So that makes sense. Corresponding parts of congruent triangles. If you have two triangles that are exactly the same, then all the corresponding parts, this angle down here, this angle over here, this hypotenuse, all those are going to be the same also. CPCTC. You'll see that a lot in proofs that once you prove two triangles are the same, then by CPCTC, you can talk about any parts of those that correspond would be the same. And that's why AC equals BD. CPCTC. All right, last one. In triangle ABC shown below, and that's the big one, side AB is 8. So I want to mark that 8, and that's from here to here, 8. And AC is 6. So I encourage you when you're taking these, maybe draw a diagram on paper. Sometimes it's easier on paper. So this is 6 and that's 8. What statement is needed to prove that DE is half the length of BC? Oh, if that would be half the length, that would make this a mid segment, because in triangles, remember, a mid is half the length of the other side, the third side. So, and it would be parallel. So how can we prove that that's a mid segment? Well, for that to be a mid segment, that means these have to be midpoints. D and E have to be exactly in the middle of the chord that they're on. So D has to be in the middle of AB. E has to be in the middle of AC. So it says AD is 3 and AE is 4. So if this was 3, A to D, is that a midpoint? Well, no, because it's 8. So that doesn't work. And that's the same. How about if AD is 4? Okay, that would make that halfway, right? If that's 4 and the whole thing is 8, that's in the middle. And AE is 6. Well, if this is 6 and that's 6, that means E is not in the middle. It's way down here on top of C. They're the same point. That can't be true. So AD is 4. If that's 3, now it's in the middle. That is our answer right there. So the things you need to pay attention to, all right here on this practice test, the things you need to know, the reflexive property, the mid-segment theorem, alternate interior angles, alternate exterior angles, corresponding angles. Corresponds means in the same position, the same place. This angle corresponds with this angle, right? Corresponding angles, vertical angles, same side interior angles. Knowing all of those theorems and what they mean, and most of them mean they're exactly the same. Corresponding angles are the same. Vertical angles are the same. Alternate interior, alternate exterior, those are all the same. The one that's not is same side interior is not the same. Same side interior actually adds up to 180 degrees. Not the same. So study those things. Be up to speed. The reflexive property that says this AC equals this AC because they're the same AC. Mr. Brock equals Mr. Brock because of the reflexive property. That's how that works. So just be familiar with those things. And you saw how I did these problems. I just went through and found out when there's multiple choice, a lot of the things they said on the choices weren't even true. So you can eliminate it. Well, that's not even a true statement. Looking at the diagram and taking what they said, it's not even a factual statement. So you eliminate it that way until you get down to where a lot of times I just had one statement that was even true, and that made it real easy. I didn't have to know a property because it was just saying things that weren't even true. So I will have the test up by Monday. Like I said, I'm still working on it. I'm kind of redesigning it a little bit. We're going to have something different than our usual test model on part 2. I'm pretty sure. I think I have an idea what I'm going to do. That will be a project you'll do on paper and upload if I don't change my mind. So do work you can be proud of. We'll see you next time.